So to graph the log of x minus 2 plus 3, first let's think about our parent function, which is y equals the log base 10 of x. And again, we prefer to think of this as an exponential, so let's flip it around. 10 to the y equals x. So we find our parent points, -1, 0, and 1. But this time we'll put them in for the y's instead of the x's, because that is our independent variable. So that's 1/10 and 1 and 10. And we plug those into the power. Let's plot that parent function. So -1 and 1/10, so that's right there. And 1, 0 is right there. And then 10, 1, we're going to have to draw some extra boxes here. Is right here. Oops. Let's fix that. We have 10, 1, and then we have 1, 0, and then we have 1/10, -1. There we go. That makes more sense. And then we swoosh it up, and we have our asymptote right here. And it looks like we are shifting this. Since our x is a liar, we're shifting it to the right 2, and then we are shifting it up 3. So we are moving to the right 2, so the asymptote is going to move 2 spots. And this point goes to the right 2, and then up 3. So 1, 2, and then up 1, 2, 3. This one goes to the right 2, and then 1, 2, 3. This one is just way off the grid, so I'm going to cheat a little bit and say we're like that. Okay. Our domain is from 2 to infinity. Our range is -infinity to infinity. And then our end behavior, the limit as x approaches infinity of my function is infinity. And then the limit as x approaches not -infinity, in this case I am approaching 2 from the positive side of f of x, is also -infinity. Now let's do this one. We have the -ln of x plus 1. So again, remember, every ln is just a log of e. So our parent function is y equals log base e of x. So if we flip it, we have e to the y equals x. Our parent points, again, e is a little bit more than 2.7. So we're going to be in between a box, which makes life unpleasant sometimes, but it's going to be okay. So this is 1 over e. I would not figure out what that decimal is. Just say 1 over e. It's about a third. And then 1, and then e. So let's plot those parent points. -1 and, or e, 1 over e and -1, so about right there. And then 1, 0. And then e, which is a little bit more than 2.5, and 1. So here we go. We have our asymptote. So this graph has a negative out front. So this negative out front multiplies to the y's. And then we are going to shift it up 1. So all of these y's get multiplied by -1. So this is now a positive 1, and that's a -1. -1 times 0 is just 0. So let's replot this with the shift in it. So we're 1 over e and now positive 1. This point stayed the same. And then e and -1. And now we're going to shift everything up 1. When we shift it up 1, the asymptote does not move. So our final graph is this red one. Our domain is just 0 to infinity. Our range, -infinity to infinity. Our end behavior, the limit as x approaches infinity of my function is infinity. So this is negative infinity. My y's are getting smaller. And then the limit as x approaches 0 from the positive side of f of x is going to be positive infinity. Our y's are getting much bigger. So let's look at this one. We have the log base 2. So log base 2 of x, y equals, there's our parent function. And we're going to flip it, so 2 to the y equals x. Let's figure out our parent points from there. Negative 1, 0, and 1. In for the y's. So 2 to the negative 1 is a half. 2 to the 0 is 1, and 2 to the 1 is 2. And so let's plot those. So we're at a half and negative 1, and 0, 1, and 2, 1. So we're like this. And we have our asymptote. And the only shift we have here is a negative 3. That's on the outside, so all the y's are getting multiplied by negative 3. So this is now positive 3. This is now negative 3. And again, 0 times negative 3 is just 0. So let's replot. 1 half and 3. 1, 2, 3. And 1, 0 stays the same. And then 2, and now negative 3. 1, 2, 3. This graph kind of stretches out. But you'll notice that your domain and range are the same as the previous one. Because our asymptote didn't change by the multiplying of the negative 3. In behavior, the limit as x approaches infinity of f of x equals negative infinity, because our y's are getting smaller. And then the limit as x approaches 0 from the positive side of f of x is negative infinity. Again, let's go through and find our parent function. So the log base 1 half of x will equal y, which means that if we flip this into an exponential, because it's easier for our brains to work with, we get 1 half to the y equals x. And so we're going to plug in negative 1, 0, and 1 here. So we get 2 and 1 and 1 half. And let's plot those. So at 2 we go to negative 1, at 1 we go to 0, and at 1 half we are at 1. And here is our parent function. And looks like everything is happening with our x's. Remember, I know a lot of you probably forgot this. This needs to be factored. So you need to factor out the x, or factor out the negative first. And so you are going to change the signs of all of the x's. And then after we plot this, then we will shift it to the right 2. So let's do this part first. This becomes negative 2, negative 1. Then negative 1, 0. And then negative 1 half 1. So we are like this. And now we're going to shift our pink graph. And our final graph will be green. So we are shifting it to the right 2. When we shift it to the right 2, we are also shifting our asymptote. So 1, 2. And so this goes here. This goes here 2 spots, and then this point is right here. So this one, our domain and range is going to be a little different. Our domain is negative infinity to 2. And our range is negative infinity to infinity. And our end behavior, the limit as x approaches, this time our limit of x is not going to approach infinity because there's no graph on this side. So it's the limit as x approaches 2 from the negative end of f of x equals positive infinity. So our y's are getting really big right there. And then the limit as x approaches negative infinity, because we go this way, of f of x equals and our y's are also getting negative and very big, so negative infinity. All right, parent function, log base 3 of x equals y, which means the exponential version of this, when we flip it around, is that. So we have 1/3 and 1 and 3. And let's plot those. Let's see, now we have to multiply that to the y. And we have to shift this to the left one. So first we'll multiply by that by -1, so that becomes a plus and that becomes a minus. And we can regraph, so 1/3 positive 1, 1, 0, and then 3, -1. Right, and we are shifting this to the left one, so we're going backwards 1. So my asymptote is now here. Let's switch colors so it's a little bit easier to read. And so this bumps back 1, this bumps right here, and this bumps right here. So our domain is -1 to infinity. Our range is -infinity to infinity. And our end behavior, the limit as x approaches infinity of f of x is -infinity. And the limit as x approaches the asymptote, which is -1 from the positive end, is positive infinity. And now let's look at this one. So it has a lot of things happening. But again, the parent function, remember, an ln is just a log with a base of e. So we have e to the y equals x. And again, this is going to lie in between boxes, which makes you upset. That's it sometimes, but it's okay. So we have 1 over e, then we have 1, and then we have e. And let's examine our stretches first. So we are stretching all of the x's. Remember, we always do the reciprocal of this. So all of the x's are getting multiplied by 3, and all of the y's are getting multiplied by 4. So this is 3 over e, this is 3, and this is 3 times e. This is -4, and still 0, and +4. So 3 over 3, remember e is about 2.7. So it's almost 3 over 3, so it's pretty close to 1. It's a little bit less than 1. So a little bit less than 1 on the x, and we're going -4 on the y. And then 3, 0. And then 3 times e, so 2.7, so we're a little bit less than 6. And 4. Oh, I never plotted my parent function. It's okay. And here's my asymptote too. And now we're going to shift this. What does it say to shift it? Up 3. So every point goes up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And here's your final graph. So your domain is 0 to infinity. Your range is -infinity to infinity. And your end behavior, the limit as x approaches infinity of f of x is infinity. And the limit as x approaches the asymptote, so 0 from the positive end of f of x equals -infinity. We'll pick up this back of the worksheet on part 2.